Welcome. In this short knowledge clip, we are going to discuss one of the main and most fundamental models for modern economics. This model is also referred to as the Marshallian cross, which is called after one of the great neoclassical economists, Alfred Marshall. So the Marshallian cross, and it's possible that he wrote his name with a single L, but I'm not so sure of that, is going to be our basic model describing how a market works. First, however, we need to discuss the components of such a model. The first component is going to be demand. Soon, we are going to learn more about the main factors behind demand and supply. But in order to introduce this simple model, we do not really have to understand deeply what makes consumers to demand some good or what makes producers to wish to supply a certain amount of goods. Instead, we are just going to simplify the issue into something which is referred to in your textbook as the law of demand. And the law of demand just simply says that if the price of a good increases, then the quantity demanded of that good should reduce. Even though this is referred to as a law, do not think that this is some kind of natural law carved in stone. But usually, in most cases, whenever a certain good is going to give you a certain amount of utility, then you are going to have this type of relationship, that is, higher the price, lower the amount of goods demanded. It is very important to distinguish between the quantity demanded and demand itself. Quantity demanded is always going to be the amount of goods which consumers wish to purchase at a given price. Demand, on the other hand, is a more general concept. Nevertheless, I will not really take it too seriously whether you use this concept always perfectly or not. But please try to be sure that the technical terms you are using are correct. How could I then formulate this relationship between price and quantity? What you should first understand that the quantity demanded for a certain good is going to be a function which I will just denote with f without making it more explicit. And we know that the quantity demanded is going to be depending on the price of good, and we know that this is a negative relationship because we assume this with the law of demand, but it will also depend on other factors. For example, the available income. It is quite logical that if you have a higher income, then you may be willing to purchase a good even at a higher price. So, if consumers are getting wealthier, having more income, then it is also likely that they are going to demand more of the good. And finally, there can be alternative goods. These goods might actually serve the same purpose like the good in question, and then they are substitute, or maybe they are necessary so that you can consume this particular good, and then they are complements. But the point is that the price of such related goods may also have an impact on the quantity demanded. If they are substitutes, then you are going to find actually a positive relationship. That is, if the price of alternative good increases, then people are going to consume more of this particular good here. So for substitutes, you would find a positive relationship, but for complements, you would find a negative relationship But this is something we are going to discuss in the next knowledge clip. Of course, in order to be able to make a graph which is two-dimensional, we have to do something with all those other factors than price. We cannot really create a 3, 4, or n-dimensional graph. We should simplify the whole problem into a problem of 2 dimensions. In order to do this, we have to use the basic concept of ceteris paribus. That is, we are going to operate under the assumption that everything else is fixed. That is, when I draw a graph, then you can assume, well, I'm going to assume that along the same demand curve, income and the price of other goods and all other factors are going to remain unchanged. Let's see an example. For example, we can say that ceteris paribus, that is, when only changes in prices are allowed to happen, QD could be written as 100 minus 10p. And this is what we call a linear demand function. Of course, there are other types of functions which can describe demand, but in this course we will make things simple, and therefore such linear forms can be expected. This is then the normal way to write up the demand. Another way would be to express this relationship not for QD, but to P instead, and then we have a so-called inverse demand function. And you can see that if you make all the necessary algebraic manipulations, then you can just simply write it. Then P equals 100 minus QD, and we divide by 10, and we have the inverse function like this. This here is going to be an inverse demand function. And this is important because the tradition in economics is that the graph is going to depict the inverse demand function and not the normal demand function, which we discussed here. So, how would this look graphically? We have here on the vertical axis P, and that's the reason why we actually are depicting the inverse demand function, because the dependent variable, left-hand side variable, this time is price. And here we have the quantity. So if you would like to depict this, then first of all, you need to know what are the intercepts. Now, obviously, for the vertical axis, the intercept is where QD equals 0, and if you substitute this here, you can see that then the price is 10. This says that at price 10 per unit, no one is going to buy any of these goods. The quantity demanded is 0. If, however, P is 0, and no, you could use actually the normal function, the normal demand function, then we find that even if the price was 0, people would not really want to have more of this good than 100. So, using the inverse demand function, we found the intercept. Connecting these intercepts is going to give us the demand function. Well, actually the inverse demand function, even though we are going to refer to this also as demand function if it doesn't cause any misunderstandings. And you could even write it D to denote that this is a demand function. So, based on this, you could find out how much demand is demanded of the good, at a given market price. Of course, even these outside exogenous factors that we assume to be unchanged, like the income denoted here by Y, or the price of alternative goods, or any other factors which influence demand may change. Now we know that the quantity demanded is going to change in a way when the prices are changing. For example, if the price from 8 falls to a price of, for example, 6, then we know that this is going to increase the quantity demanded. This can be seen as a movement along the demand curve. If, however, some exogenous factor other than prices change, then you cannot really depict the change in this way. Why? Because we assume that along the same demand curve, these exogenous factors remain the same, but we know, look at the situation when this is not true. So, for example, when the consumers experience an increase in their income. Now, the original relationship was like this. And we are going to pull this D. Now, we can assume that if the income increases, then even with the same price as before, say 5, the consumers are going to be willing to buy more goods than before. For example, they are going to be willing to buy 100 units for a price of 5 per unit. Obviously, when one of these exogenous factors, in this case income, is changing, then we are not anymore along the same demand curve. So instead, we experience a shift of the demand curve. And we are going to have different intercepts. But the slope of the curve is still the same. So the shifted new demand curve is parallel to the original one, and we can just call it, for example, D prime. If some other factor reduces the quantity demanded at any prices, then we can do this the other way around and just say that the demand function is shifted to the left. So the demand function is going to shift to the right when there is a positive shock, a positive change in the exogenous factors which influence demand, and when the shock is negative, then we have a leftward shift in the demand function. The next component of the Marshallian cross is supply. In the next week, we are also going to look at a model which would explain us how the firms decide how much goods and services they are willing to supply. For now, we also have to use a simplification, a law of supply, which just simply says that the higher the price, the more of the good and service will be provided or supplied. Graphically, this means that we have an inverse supply curve like this. That is, that there will be a certain price below and at which simply no goods and services are provided, but as prices increase, then the quantity supplied is going to increase. So the supply curve, and the inverse supply curve in this case, is going to be positively sloped. We could also write this up in a more algebraic way by simply saying that Qs is again a function, which now I will denote by G, and we say that It depends on the price of the good itself, and it depends on it in a positive way, but it may also depend on other stuff. For example, the cost of production, or it may also depend on technology and all kind of supply shocks like weather. So there are a lot of factors which we need to keep constant along the same supply curve. So again, we are using here the concept of ceteris paribus. Again, just like in case of demand function, we can also model the effect of positive and negative supply shocks. For example, it may happen that a producer experiences an increase in cost, or perhaps some natural disaster destroys some of the basic materials for the production of that particular good and service. So, for example, if we look at here, for example, the supply of grain in the market, then it's possible that bad weather would just simply destroy an amount, a considerable amount of the harvest. In this case, you will find that even at a certain price which would provide us with fewest amount of good supply, then this is just P So even at this price, it is not possible due to the shock anymore to supply the same quantity. For example, if the half of the harvest is gone, and actually even at this price, we can only supply half of the original quantity. So you can see that we are again along a different curve, and we experienced a negative supply shock, which resulted in a leftward shift of the supply curve. A positive shift may also happen. For example, if somehow the cost of production reduces, or there was some kind of especially good weather conditions which make it possible for the firms to supply more goods at the same price than in the initial situation. And then, obviously, we would find that this point must be along a new supply curve, or line in this case, S2 prime, and this is going to be the rightward shift, an effect of a positive supply shock. The next step is to combine the supply and the demand model to arrive at a partial equilibrium model. Partial equilibrium is called partial because it is only about the equilibrium in the market of a single good. So, if we just put both functions into the same two-dimensional coordinate system, then we are going to get a demand, inverse demand function, and an inverse supply function. Now, what is the main idea here is that market mechanisms will always work so that all disequilibrium, that is all over or under supply, or excess demand, or inadequate demand, is going to be eliminated by the market through the change in prices. So the idea is that if, for example, the prices are high, for example at this level, then the market is obviously not in equilibrium. At this price, namely, the consumers are only going to demand QD1 amount of good. On the other hand, because of the high prices, theoretically, the suppliers would be very happy to supply a much higher amount of the good. Obviously, most of these supply will not really appear in the market because the demand is much lower. So actually the quantity traded in the market will be determined by the quantity demanded. We can also say that the quantity demanded is a bottleneck. So what we have here is an excess supply. And this excess supply going to show us how much more the suppliers are willing to supply and sell in the market than what actually is demanded. Let's see another possible situation when we have low prices. So if here, for example, I can say P1 was the previous price, but instead now we have P2. What's going to happen is just the reverse of the previous case. Here, because of the low prices, actually more of the goods is demanded than what is actually supplied by the producers. This is here what we call excess demand or shortage, depending on the textbook. These situations are disequilibria. So when any of these situations happen, then there is no equilibrium in the market. Pardon? So disequilibrium is the singular and disequilibria is the plural. So it is the lack of equilibrium, which means that the quantity demanded does not equal the quantity supplied. So the main idea is behind this model is that the prices are going to adjust in this market so that finally the quantity demanded and supplied will equalize, and at that point we are going to have an equilibrium. How could this happen? Imagine the first situation when we had the high price. So the price was so high that actually consumers were not willing to buy all the goods supplied offered by the seller. In this case, sooner or later, the seller is going to build up so much cost that the seller must be willing to reduce the price. So what's going to happen that slowly the supplier will be willing to reduce the price, accept a lower price, so that slowly the demand is going to increase. So this mechanism here would then drive the prices to that particular level when an equal amount of the good or service is demanded and supplied. And this is giving you P star here, which I'm going to use to denote equilibrium price. And the quantity at which this is true is equilibrium quantity Q star. So when QD equals QS, which is nothing else than Q star, then we have an equilibrium in the market. Similarly, what if the prices are lower than the equilibrium price? In that case, the consumers who simply cannot buy the goods and service because at this low price there is just inadequate supply will be willing to pay a higher price. As a result, slowly, we are going to go back to the equilibrium price and quantity. Using this simple model, we can model any situations which would affect the market. Let's see some examples. Imagine that we have here a market for grain. Initially, we can characterize this market by an inverse demand and a certain inverse supply function, and initially we can assume that we are in equilibrium in the market at P1 star and Q1 star. Now, it is possible using simply shifting the different curves to model what's going to happen if something unexpected, some kind of change in the exogenous factors, we call these shocks, occur. So let's assume that for some reason people think that consuming grain is much more, so it's healthy and actually much better for the environment. For that reason, they are going to just, at given price, demand more of grain. So what's going to happen here? Obviously, this must be a demand shock. So at given price, people are going to buy more grain, which is going to then appear as a rightward shift of the demand curve. What's going to happen here? Slowly, starting from the previous equilibrium, the market is going to converge toward the new equilibrium, which we are going to call Q2 star and P2 star. So a positive demand shock resulted in an increase of prices and the quantity traded in the market. A similar situation could happen when, for example, similar situation could also happen if we have a change in the factors affecting supply. So let's assume that there is a bad harvest, which would just simply cause a leftward shift of the supply. So if we had the original Q1 star and P1 star here, then in this new equilibrium, in case of a negative supply shock, you would find that at the new equilibrium prices are higher than before, but altogether still less goods are traded. What happens if both of these factors happen, so both of these shocks happen at the same time? Then you can, of course, apply the shift on the supply and the demand curves in the same diagram. Then we could have a situation which is not so obvious anymore as it was before. So we start with the supply and demand functions. Needless to say, these are of course all inverse supply and demand functions, and we have an initial Q1 star and P1 star, equilibrium quantity and prices respectively. Now we are going to experience then a positive demand shock, but at the same time there is a bad harvest which causes a negative supply shock, and we have a leftward shift of the supply function. Now, as you can see, even though the increase in demand acts in the direction of increasing quantity traded, the reduction in the supply, so the negative supply shock, is going to counter this effect. So in this case, for example, we would find that the two effects, so the two shocks, are just going to offset each other, and actually Q2 star is just the same as Q1 star. What is going to happen, however, is that finally prices are going to be higher than before. There is an interesting regularity here. So if you have the demand function, a demand shock, then prices and quantities went into the same direction. In case of a positive demand shock, both increased. In case of a negative demand shock, both decreased. In case of a supply shock, the change in price and quantity had the opposite sign. In case of a positive supply shock, you would experience lower prices and higher amount of goods traded in the market, and in case of a negative shock, you would find higher prices and lower quantities. If you experience two shocks, one quantity and one supply and one demand shock at the same time, then it is not obvious what is going to happen to the quantity traded. After all, a supply shock may dominate a demand shock or vice versa. What will happen definitely in case of a negative supply shock paired with a positive demand shock, so in this particular example, is going to be an increase in prices.